Alright, we're back on the back side of the 5.5 Day 2 notes, and we're listing our possible rational zeros. Now this one's a lot less work because our p, which is your constant term, is just a -1, and there are only factors of -1 as plus or minus 1 are the only numbers that multiply to be 1. And the q is your leading coefficient, and on this one q is 2, and again the factors for 2 are really pretty short, just 1 and 2. And so our possible rational zeros, which are all the possible p's divided by all the possible q's, we are going to have plus or minus 1 over 1 is just 1, and 1 over 2 is just 1/2. And so for this list, we only have 4 numbers, positive 1 and -1, and positive 1/2 and -1/2. And then we're asked to find the actual rational zeros. So without a graph or without any help from a calculator, we just need to take our original polynomial and see if any of these work. And so I could choose 1, I could choose -1, I could choose 1/2 or -1/2. I'm just going to say, let's try -1. So I'm going to do the synthetic division that you learned earlier. So we have a 2x cubed, a 5x squared, a -6x, and a -1. And in the box off to the side, I wanted to try x as a -1, which comes from our list of possible rational zeros. I could have chosen positive 1 or positive 1/2 or -1/2. And I'm hoping that it's an actual zero, and so the remainder will be 0. If I get something other than 0, I need to try a different number and keep working at it. So our first term comes down. We multiply. 2 times a -1 gives me a -2, and we add down to get 3. Now we multiply. 3 times a -1 is a -3, and we add down to get -9. And one more time, we're going to multiply. -9 times -1 is positive 9. Add down to get 8. -1 is not a 0. So I chose the wrong number from the list of possible rational zeros, unfortunately. So I'm going to have to try another one. So we do the same setup. My coefficients are 2, 5, -6, and -1. But this time, instead of trying a -1, I'm going to try a positive 1. So we bring our 2 down and we multiply. 2 times 1 is 2. 5 plus 2 gives me 7. 7 times 1 is 7. -6 plus 7 gives me positive 1. 1 times 1 is 1 times 1 is positive 1. We add to get 0. And this time I do have a remainder of 0, whereas the last time I had a remainder of 8. And so because my remainder is 0, I know x equals 1 is one of my actual rational zeros. Alright, at this point we could still keep going with the synthetic division, and I could try the 1/2 and the -1/2. But it could be that our other zeros are not rational, not a number positive or negative divided by another positive or negative number. It could involve a square root and be irrational, or we could have some imaginary numbers. And so from here, it's faster usually if you can go from a third power to a second power, which is what we just did when we divided. We now have 2x squared plus 7x plus 1 using these coefficients. Now we have a quadratic, and from here it's usually faster just to do the quadratic formula or to do a box. And if I look at the numbers that I have, if I were to set up a box, when I take my first term times my last term, I'd be looking for numbers that multiply to be 2, that add to be 7, and there are no numbers that multiply to be 2 that add to be 7, so a box would not work here. So we are going to have to use the quadratic formula to find the last 2 zeros. They're not going to be 1/2 or -1/2. They're going to be irrational. So the only rational zero is 1. So if we look at the quadratic formula, we're going to have x is equal to a -b, so -7, plus or minus the square root of b squared. So our b is 7, 7 squared, minus 4 times a, which is 2, times c, which is 1, all over 2 times a, and again 2 times 2, or a is 2. Alright, I'll turn this straighter for you guys. So using the quadratic formula, we have a -7 plus or minus the square root of, well, the 7 squared is 49, minus 4 times 2 is 8, times 1 is still 8. So we have 49 minus 8, which is 41. So the square root of 41 all over 4. And from here, there's nothing else I can do. I can't simplify the square root of 41. There's no perfect square that goes into 41. And so this is my other two zeros, the two irrational zeros that we got from the quadratic formula, and also x is 1 that we used with our synthetic division to get a remainder of 0. So we had to do some guess and check because we didn't know which of these possible rational zeros were actually a rational zero. On number 3 here, we have a graph to help us, and that is kind of nice. So looking at this right away, I see that I have x cubed plus 4x squared plus 7x plus 6 as my function, and I can see that I have a 0. It crosses my x-axis at x is a negative 2 right here. And so from here, I'm going to use synthetic division, and I'm going to use negative 2 off to the side because that should be a 0. I should get a remainder of 0. So we have 1x to the third, 4x squared, 7x, and 6. And again, be sure you're not missing any x powers. We have third power, second power, first power, and constant. And from the graph, I can see negative 2 is one of the zeros. Okay. So if I bring my first term down, 1 times negative 2 is a negative 2. We add down, and we get 2. Then we multiply again. 2 times negative 2 is negative 4. We're going to add down, and that gives us 3. 3 times a negative 2 is a negative 6. We add down, and the remainder is 0, which is what we expected. So now, instead of a third power, we're going to have a second power. We have 1x squared plus 2x plus 3. All right. Now, we could try a box here. Factors that multiply to be 3 are 3 and 1, but 3 and 1 are not going to add to be 2. So again, we're forced to do the quadratic formula. Our a is 1, our b is 2, and our c is 3. So we have x is equal to a negative b plus or minus the square root of your b squared minus 4 times a times c all over 2a. So that gives us negative 2 plus or minus. This is 4 minus 4 times 1 times 3. That's 4 minus 12, which will give us the square root of a negative 8 all over 2. Now, because we have a negative underneath our square root, we're going to need to take that as I. So we have negative 2 plus or minus I square root 8. So the negatives come out as an I. And sometimes we would be done, but there is a perfect square that goes into 8, so we're going to keep going. Whereas on the last example, there was no perfect square that went into 41. But we know 4 and 2 go into 8. And so I'm going to rewrite this as negative 2 plus or minus I square root 4 square root 2. 4 times 2 is 8 all over 2. So we have a negative 2 plus or minus. So the square root of 4 is 2. So I have 2i squared root of 2 all over 2. And this does reduce using your heart method. Negative 2, 2, and 2 all divide by 2. So we get negative 1 plus or minus 1i square root of 2 all over 1. So our zeros, there's 3 of them. We have 2 right here, and then also the negative 2 from the graph. Those are your 3 solutions. Okay, and then last of all, number 4, this is review, just to get you ready for your upcoming quiz and test. If we have given roots or given zeros of negative 5 and 13i, remember imaginary numbers always come in pairs, so we need to remember to write negative 13i as well. So there's 3 zeros, so we should end up with a cubic. So we're going to have y equals in factored form x plus 5, x minus 13i, and x plus 13i. And we have to multiply the I parts together first. So we get x squared plus 13ix minus 13ix, and then minus 169i squared. And our x plus 5 comes down. The middle terms cancel, so we have x squared. And then remember, I squared is a negative 1. So this is really negative 169 times a negative 1, which is plus 169. And we just need to multiply one more time.
So x times x squared gives us x cubed. X times 169 gives you 169x. 5 times x squared is 5x squared. And 169 times 5, 9 times 5 is 45. 34. 5 times 1 is 5, 6, 7, 8. That's 845. And so finally, if we put this in the right order, we have y equals, we have our x to the third, plus 5x squared, plus 169x, plus 845.